Find resultant of two or more vectors by component method. You have to split each vector into horizontal and vertical components, then add components along horizontal direction, add components along vertical direction, then find their resultant applying parallelogram law. Then multiplication of vectors. Multiplication of vectors. If a vector is multiplied by a scalar, the product will always be a vector, which we saw yesterday. It's just ordinary multiplication, nothing new. Okay. Now, if you multiply a vector by another vector, then you can do that in two ways. Product of vector and vector can be a scalar or it can be a vector. If the product is scalar, you call it as scalar product or dot product. And if the product is vector, you call it as cross product or vector product. Now let us see these two products today. Scalar product and vector product. Scalar product and vector product. Scalar product first. Another name is dot product. What is this? See how actually the scalar product is defined is you have two vectors. This is vector P. And this is vector Q. Vector Q. And these two are making some angle theta with each other. Now the vector scalar product of these two vectors P and Q is defined as it is given as P dot Q. See how we write the notation, the uh, representation that we follow to represent or to show scalar product is normally if you take ordinary multiplication of integers, how do you write it? Suppose I want to multiply 2 with 3. Then I write it as 2 into 3. This is the symbol of multiplication. This is the symbol of multiplication, algebraic multiplication. Like how plus, minus, divided by are symbols. Cross mark is the symbol for multiplication, ordinary multiplication. Here, to represent that it is a special multiplication or multiplication of vectors, that to scalar product of vectors, we are putting a dot here between P and Q. P dot Q. And you don't read this as P into Q. You read this as P dot Q. Not P into Q. It is P dot Q. That's why its another name is dot product. P dot Q. Okay. This tells you this, from this you should understand that there is one vector V and there is another vector Q, and you are going to perform scalar product on these two vectors. You are going to perform scalar product on these two vectors. Okay. Okay. So how much is P dot Q? 2 into 3 is equal to 6, right? How much is P dot Q? P dot Q is given like this. PQ cos theta. What do these terms mean? What is the difference between this P and this P? Are they same or different? They are different. This P is vector P and this P is magnitude of vector P. I hope you remember. We represent magnitude of a vector by putting that vector between two lines, mod A or magnitude of A. So this is magnitude of vector P. And what is this? This is magnitude of vector Q. And everyone, I hope, remembers and knows how to find magnitude of a given vector. Right. Then theta. What is theta? Theta is the angle between vector P and vector Q. This is how scalar product is performed. P dot Q is equal to PQ cos theta. Vector P dot vector Q is equal to magnitude of vector P multiplied by magnitude of vector Q multiplied by cos of angle between P and Q. Okay. So P dot Q is equal to PQ cos theta. Right. Now, if we take some properties of this, if theta equal to 0 degree, theta equal to 0 degree means the two vectors are parallel to each other. Then cos 0 is equal to 1. That means P dot Q is equal to PQ.
Sir,
P dot Q is equal to PQ. And cos theta is 0 degree. If theta equal to 180 degree, that means how will be the two vectors? They will be anti-parallel, opposite to each other. 180 degree. Then cos 180 degree is minus 1. That means P dot Q is equal to minus PQ, because cos 180 is minus 1. Another case, if theta equal to 90 degree, 90 degree means the two vectors are perpendicular to each other. Then cos 90 is 0. That means P dot Q is equal to 0. P dot Q equal to 0. And this is an important point, or a note to be made is, if two vectors are perpendicular, then their dot product is 0. Important point. You get many questions based on this point. If two vectors are perpendicular, then dot product will be 0. Or conversely, if dot product of two vectors is 0, then it implies the two vectors are perpendicular to each other. So you can check the condition whether vectors are perpendicular or not by performing this dot product on the two vectors. If you get product 0, they are perpendicular. Non-zero, they are not perpendicular. Then dot product is commutative. Dot product is commutative. Commutative means P dot Q, they have same value. A equal to B like that. Dot product is commutative over vectors. Okay. Then important point, for unit vectors IJK, for unit vectors I, J, K, what will be the dot product? See, Try to understand. I want to do I
Sir,
dot.
sir, have a
Yes.
doubt. One scroll up. Yes, sir. Here we have a scalar product now, sir. That means
Yes, scalar product.
yes, sir. That means we do vectors in scalar type, or we do scalar multiplication. Is it used for scalar multiplication or vector multiplication, sir?
Vector multiplication. We are discussing about vector multiplication. We are multiplying two vectors. There is no need to discuss about scalar multiplication. No, you already know it very well. 2 into 3 is 6, 9 into 9 is 81, 6 into 10 is 60. It need not be taught to you. We are discussing vector multiplication here. Vector multiplication can be done in two ways. It can be two, uh, it will give you two types of results depending on their nature. One is you can get either a scalar quantity or a vector quantity. If you get a scalar quantity by multiplying two vectors, you call it as scalar product. If you get a vector quantity by multiplying two vectors, you call it as vector product.
Sir,
Yes.
Sir, if we multiply two vectors and we get a scalar product, so that means we should just remove the direction, sir.
No, you don't remove the direction. You will understand that at the end of this topic.
Sir, now what should we write as our direction, sir?
You will not get direction. If you get direction, that is a vector. Right?
Okay, sir.
sir, for
If you get a direction, that
Sir,
will become a vector.
Sir, how will we know if we multiply two vectors that will be a scalar or vector?
It depends on the method that you apply. If you perform scalar product, you will get a scalar. If you perform vector product, you will get a vector. Mathematically. Physically speaking, it depends on the nature of the two vectors that you are multiplying. I gave two examples yesterday. If you multiply force vector with displacement vector, you will get work, which is a scalar.
Okay, sir.
sir,
Yes.
sir, you told us magnitude of vector P and Q are shown in between two lines. So when we multiply, when you told us when theta is 0, vector P into vector Q equals to PQ, then what about the lines?
You have to take the magnitude. Do you know how to find magnitude of a given vector? Do you remember
Yes,
it? How?
Yes.
Suppose xi plus yj plus zk is one vector. What is its magnitude?
X plus Y plus Z.
No. If xi plus yj plus zk is one vector, what is the magnitude of that vector?
Sir, root of
We did many questions. Root over x square plus y square plus z square. That is the magnitude. Okay, you listen to this completely. That's why I always keep telling, if you listen to a topic completely until I finish it, then 70-80% of your doubts will be clarified by the end of the topic. If you just develop that patience of holding your doubts and listening up to the end of the topic, 70-80% of your doubts will be clarified during the explanation. Still, some special or extraordinary doubts that you might get, they can be discussed. Now, if you take the scalar product or dot product of unit vectors, ijk are unit vectors. I hope you remember this ijk. I is unit
Yes,
vector.
sir. They are directions, sir. They are
A is
directions
unit
for
vector of
the
y direction.
coordinate geometry, sir.
Is, unit vector along z direction. Ijk are unit vectors along x, y, and z directions. Now I want to perform scalar product on these unit vectors. Unit vectors are also vectors. So I am multiplying I with I with I dot I. As per the definition of scalar product, P dot Q is PQ cos theta. P dot Q is PQ cos theta. In place of P, you have I. In place of Q, also you have I. So if I apply that formula here, PQ cos theta, I should get magnitude of I multiplied by magnitude of I cos of angle between I and I. I am not writing a new formula. I am applying the formula of scalar product to unit vectors. P dot Q is equal to PQ cos theta. I dot I is equal to I into cos theta. Okay. Now, what is the magnitude of I? By definition, I is a unit
One,
vector.
sir.
And by definition of vector, magnitude
No,
of
sir.
unit
One,
vector
sir.
will
Root
one.
of I square plus square.
Magnitude of unit vector is 1. Unit vector is a vector whose magnitude is 1. That's how we defined it. You should not forget the basics. Before, whenever you find time or you take out some time, revise the basics once. It's not only the current topic that you should remember and that you should understand. All the previous topics are equally important. By forgetting the previous topics, you cannot learn the present topic. And by forgetting the present topic, you cannot learn the coming topics. So every time that continuity must be there. You should be remembering and you should be having clear idea of what has been taught to you. Otherwise, it will be like starting fresh every time, which does not help. So I is a unit vector, and by definition, magnitude of unit vector is 1. This I is also unit vector, so its magnitude is also 1.
So cos theta is also 1, sir.
Cos theta. Theta is, what is theta as per the definition?
Zero,
It is the angle between P and Q. What is P here? I. What is Q here? I.
Zero,
And
sir.
theta is angle between I and I, which is 0. Because I and I both will be parallel to each other. They are the same direction. So theta will be 0. And we know cos 0 is 1. So 1 into 1 into 1 is 1. What does this mean? This means the product, the scalar product of I and I, you are getting 1. Similarly, if I do J dot J, magnitude of J cos theta. Magnitude of J is 1. Magnitude of J is 1. Theta is 0 degree between J and J, same direction. 1 into 1 into 1, which is also 1. If I do K dot K, magnitude of K cos theta. 1 into 1 cos 0. 1
Sir,
into
why
1
is
into 1,
cos
1.
theta 0, sir?
What is theta? Theta is angle between what and what?
P and Q, sir.
Where are P and Q here? We are multiplying I and I.
Yes, sir, I and I.
So what is the angle between I and I?
0, sir.
That's what I have written there. Right?
Sir.
Got it or not? Okay. This is one thing. Further, see. Now I will do I dot J. I will do I dot J. Again, as per the definition of dot product, I dot J is magnitude of I, magnitude of J cos theta, angle between I and J. Magnitude of I is 1. Magnitude of J is also 1.
Cos 90 is 0, sir.
Angle between I and J is 90 degree. I is along X direction, J is along Y direction. So theta is 90 degree. 9 cos 90 is 0. So product is 0. That means dot product of I and J, I dot J is equal to 0. I dot J is equal to 0. If I do J dot K, magnitude of J, magnitude of K cos theta, 1 into 1 into J is along Y direction, K is along Z direction. Both are perpendicular. Angle is 90 degree. 0. k dot I, magnitude of k, magnitude of I, cos theta. 1 into
Sir?
1 into k is along z direction, I is along x direction. Angle is 90 degree, which is again 0.
Sir, I have a doubt.
Ah,
Sir, the angle between x-axis and z-axis is 90 degrees.
yes.
Then why is that z-axis in that direction, sir?
Z axis is it?
It doesn't make it, sir. 90 degrees, no, sir. It looks like it doesn't make a 90 degrees angle.
Are you seeing XYZ axis in 2 dimensions or in 3 dimensions? How do you think they will be? In 2D or 3D? Can you visualize how these 3 axes look like? 2D?
3D, sir.
3D. If they are in 3D, can Z axis be perpendicular to X axis or not?
Oh, yes, sir.
And if you remember, I told you to do a exercise also on this when I taught you unit vectors.
Yes, sir, with fingers. I did know that only.
No, not fingers. You might get confused with fingers. You take any corner of your room as origin and identify XYZ axis. Will they 3 be perpendicular to each other? Take one corner of your room as origin. The line horizontal will be x-axis, other vertical line will be y-axis, and the third line will be z-axis. How is x and z perpendicular or not?
Yes, sir. Perpendicular.
So I dot j, k, j dot k, and k dot I all are 0. Okay. So from this, point to be noted, understood, and remembered is I dot I is equal to j dot j is equal to k dot k, which is equal to 1. I dot j is equal to j dot k, which is equal to k dot I, which is equal to 0. This is scalar multiplication of or scalar product of unit vectors. Again, if two vectors are given to you, p and q, making angle theta with each other, their dot product will be pq cos theta. Magnitude of p, magnitude of q, cos of angle between the two vectors. If theta is 0, dot product is pq. If theta is 180, dot product is minus pq. Theta is 90 degree, dot product will be 0. Then it is commutative. If you perform this scalar multiplication over unit vectors, you get this result. Next.
Sir, once can you scroll up? Yes, sir. Okay, sir. 1 minute.
Sir, what is the answer of I into J into K?
You multiply I into j, you will get 1. You multiply that 1 with k, what do you get?
1, sir.
1.
Sir, how, sir?
Actually, it is triple product. We don't have that triple product in +2 syllabus, up to +2.
Okay, sir. Sir, and I have a doubt in addition, sir.
Let us finish this thing first. Let us finish this thing. For unit vectors. Next. Suppose if you are given two vectors p and q like this in component form. If vector p is given as pxi plus pyj plus pzk, this means px is magnitude of vector p along I direction, py magnitude along j direction, pz magnitude along k direction. And the second vector q is given as qxi plus qyj plus qzk. Then if you perform scalar product on p and q, how you do it? You do it like this simply. Multiply I with I, j with j, k with k and add all of them. Okay. So it is px qx I dot I plus py qy j dot j plus pz qz k dot k. And we know I dot I, j dot j, k dot k all are equal to 1. Therefore, vector p dot vector q is equal to px qx plus py qy plus pz qz. Example to understand this. Vector p is I plus 2j minus k. Vector q is 3i plus 3j minus 4k. Vector q. Now, p dot q is equal to multiply I with I, j with j, k with k, and I'll add them. Px qx, which is 1 into 3.
Sir, is it 2J?
See, 2 into 3 plus minus 1 into minus 4. We should be careful with negative sign while multiplying. This is not any physics, this is mathematics. So you should be knowing. 1 into 3 is 3, 2 into 3 is 6, minus 1 into minus 4 is plus 4. So it is 13. Remember, the thing that we are talking about is scalar product. Fundamentally, what is scalar product? If you multiply two vectors, you get a scalar quantity. Vector into vector equal to scalar. This is what scalar product says. So the product, the end result that you get after performing scalar multiplication should be a scalar quantity. You won't get ijk's. If you get ijk's, that's a vector. How can it be scalar multiplication? Got the point? So during the process of this multiplication, you have ijk's, but they will become 1. I dot j becomes 1, j dot j becomes 1, k dot k becomes 1. You don't get ijk's here, ijk's here. Remember this point. This is how you can perform scalar multiplication on any two given vectors. If they're given in component form, you apply this multiplication. If they are given in this what you call this graphical form, you apply PQ cos theta. Okay, let us take example for that also. Let us say we have okay, before this, one more point. One more application or one more use of this dot product is
Sir, dot product means A bar into B bar or A bar dot B bar. It is only known as dot product. Sir.
no, there are no bars here. Your bars will be in mathematics. You don't read that like bar. It is vector. A vector, B vector, P vector, Q vector.
Okay, sir.
To find angle between two vectors. We can also use scalar product to find angle between two vectors. How can we do it? See, we know P dot Q is equal to PQ cos theta. That means from here we can write cos theta as P dot Q by PQ. Okay, I will put mod also. P dot Q by magnitude of P into magnitude of Q. From this you can find angle between two vectors. Okay, if you take a example, just a minute, I will take this one so that you will get some good result. 1 minute.
Sir, your voice and screen is stuck, sir.
No, I'm not speaking anything. That's why you're not getting my voice. So one example for finding angle between two vectors. Using scalar product. Yes, this one. Find angle between two vectors A 2i plus j minus k, B I minus k. How to do this? See, simple. Vector A is this, vector B is this. We know A dot B is equal to A B cos theta. We want angle between A and B. Angle is in theta. So cos theta is equal to A dot B by AB. Okay. Now, how much is A dot B? First of all, I will calculate A dot B here. A dot B is AX BX plus AY BY plus AZ BZ. Okay. Just as how we did the previous example. A dot B is 2 into 1. No I, no I, no I's, no J's, no K's. 2 into 1 plus for J. What are the questions? Here we have 1 for J and here there is no J. In vector B there is no J. So it is 1 into 0 plus K, it is minus 1 in A and B it is minus 1. So A dot B is 2 plus 0 plus 1, 3. A dot B is 3. Okay, fine. A dot B is 3. Now we also need magnitude of A and magnitude of B. How much is magnitude of A? How much is magnitude of A? Magnitude of A is root of 2 square plus 1 square plus 1 square. 4, 5, 6, root 6.
Sir, minus 1 square, na, sir. Sir, K.
What is minus 1 square?
Oh, okay, sir.
Magnitude of vector B is root of
Root 2.
square plus 1 square. Root 2. Now put all these values here.
Sir, I
and
have
cos
a
theta.
doubt. Sir,
Yes.
sir,
Yes.
sir, the magnitude of the resultant is square root of p square plus q square plus 2pq cos theta, no, sir?
That is the magnitude of resultant. Where are we doing resultant here? Are we trying to find resultant of A and B, or are we trying to multiply A and B?
Multiply, sir.
Uh,
The magnitude of vector A is p square plus q square plus.
If you have a vector xi plus yj plus zk, then the magnitude of that vector will be this. Okay.
Okay, sir.
So put A dot B
Thank
and
you,
AB values here. Cos theta is equal to A dot B is 3 divided by magnitude of A is root 6. Magnitude of B is
Angle is 60 degrees.
Sir, 2 root 3, sir.
Angle 60
Okay.
degrees.
root of 12. I can write root 12 as 2 root 3.
Sir, root 3
root
and
3.
root 3 by
Sir, root
means
3 by 2 is equal to 60 degrees.
Sir, theta is 60.
Theta is 60 or 30.
Sir,
Sir,
60.
30, sir. 30.
Cos 60 is 1 by 2. Cos 30 is root 3 by 2. So angle between these two vectors is 30 degree. Like this, you can find angle between any two given vectors by doing dot product or by using dot product.
Sir, root 3 is 3, sir.
Yes.
Sir, can you scroll up?
Sir, I have a doubt. Sir, A dot B. Sir, A dot B means we also have to
A dot-
include cos theta, no, sir.
Yes.
Sir, A dot B is equal to magnitude of A into magnitude of B into cos theta, sir.
Oh,
Sir, so then A dot
yes,
B
it
is
is into cos
then
theta.
we also had to multiply cos. Sir, then we had to multiply the
Do you
magnitudes only,
know
no, sir.
how much
A
is
dot B and magnitude of
do, oh,
both are the same, no, sir, in that way.
we are multiplying only magnitudes. No? I am finding magnitude of A dot B. I am finding magnitude of A, magnitude of B, multiplying them.
Sir, I have a doubt.
Sir, so A dot B
Oh,
means we have to multiply the directly, sir, and magnitudes means root of all the directions magnitudes.
yes, yes.
Okay, sir.
Sir,
Thank you, sir.
Hmm.
sir, I have a doubt, sir. Sir, so
Hmm.
when we multiply unit vectors, this cos theta and uh, I and j and k all are constant, right? Like they have fixed value.
Unit vectors, yeah, they have fixed value, which is 1.
Sir, and another doubt is, sir, for example, as in the question you told, j is mentioned in one vector and is not mentioned in another vector. So in another vector, you should take it as 0, right?
Yes.
Okay, sir.
Sir, I
B
have a doubt.
has no magnitude along J direction.
Sir,
No,
sir, didn't understand the right part, sir.
we didn't understand the
Right part, sir.
right part. This part.
Yes, sir.
Did you understand this
Yes, sir.
thing?
Yes, sir.
It is the same thing.
No, sir, that black color I didn't understand, sir.
That means you did not listen to the earlier classes carefully, right? If you are given a vector, does a vector has both magnitude and direction?
Yes, sir.
How can we find magnitude of a given vector? How can we find magnitude of a given vector? If I give you a vector A, which is xi plus yj, what does it mean? This vector has some value x along I direction, some value y along j direction. What is its resultant value? Actual magnitude. Magnitude of vector
X
A will be root of x square plus y square. If this has zk also, then it becomes root of x square plus y square plus z square. So if you have any more confusion regarding, go back to the previous classes. You find that lecture. Introduction, I think we discussed this in first or second class of vectors. I think second class of vectors. So you open that recording, go through that once again.
Okay, sir.
Next. You try this question, try to solve this.
Sir, we can't see the question.
Not this one. Mm, this question homework for you. Then this question also. Homework questions. Try to solve them.
Sir,
If you don't get, we'll discuss tomorrow.
sir,
Yes.
sir, once can you scroll up? Sir,
Yes.
sir, we had done dot product now, sir.
Hmm.
If we do in cross product also, we'll get the same answer only.
You will know that after you know cross product, right?
Okay, sir.
You cannot get same answer because cross product is conceptually different, dot product is conceptually different. Dot product will give you scalar quantity, cross product will give you a vector quantity. A vector cannot be equal to a scalar.
Okay, sir. Sir, once can you scroll down the sums, sir? The sums. Yes, sir. 1 minute. Sir,
Oh,
the positive value of A means if we get negative, that
you
means
ignore it. You ignore it.
we should only take the positive value of A.
Yes.
Sir, I got the answer for first one.
Okay, good. So let everyone try. You tell me the answers tomorrow. Everyone should tell the answers to both the questions. The first one, definitely. Second one, you have to try. If you get it well and good, otherwise we'll discuss.
Okay, sir.
Right. See you.
Sir, I
Good
got
night.
the second answer.
Okay, fine. We'll confirm tomorrow.
Bye, sir. Thank you.